Hey guys, we're going to learn about graphing quadratic functions. So turn to your page 27 of your packet and we're just going to go over this page. So you have your standard form of y equals ax squared plus bx plus c. We're going to be able to identify the properties without graphing, such as if a is positive, our graph will have a minimum and it will open up. If a is negative, the graph will have a maximum and it'll open down. Very similar to when we were solving absolute value functions. Now the new thing is axis of symmetry is going to be negative b over 2a. You're going to find the b and the a from your equation and you simplify that. Negative b over 2a is also the x of your vertex. Once you solve for the x of your vertex, you're going to substitute that number into your equation to solve for the y of your vertex. All right, so we're going to solve for our axis of symmetry and a vertex. This problem is from page 30, number 1. We have y equals x squared plus 8x plus 15. Our a is 1, our b is 8, and our c is 15. So we're going to substitute the 1 and the 8 for our formula, negative b over 2a, to solve for the axis of symmetry. So 8 is our b, and 1 is our a. We're going to simplify this to get negative 8 over 2, which is negative 4. That means x equals negative 4 for our axis of symmetry. This is also our x of our vertex. So we're going to substitute negative 4 into our equation to get the y of our vertex. So we're going to substitute the following. I'm going to simplify. Negative 4 squared is positive 16. Positive 8 and negative 4 will give us negative 32 plus 15. When you simplify this, you're going to get negative 1. So the y is negative 1 of our vertex. Now, since we have our axis of symmetry and a vertex, we're going to plug it in and actually graph it. Our vertex is at negative 4, 1, 2, 3, 4, negative 1. We do not have a value for any other points, but we do know since a is a positive, our graph is going to go up and it's going to have a minimum. So since this is the smallest point of our vertex, there should be a value for negative 3 that is going up, which is going to be exactly the same value for negative 5 because of the axis of symmetry. Whatever is on the right side will be a mirror image of the left. So let's try plugging in negative 3 in our equation here. So y equals negative 3 squared plus 8 times negative 3 plus 15. And let's simplify. 9 minus 24 plus 15. Simplify this to get 0. So if it's helpful, use a table. We already know that x is negative 4 will give us negative 1. And now we know that if x is negative 3, we're going to get the value of 0. We can plug that in. And we can use our axis of symmetry to figure out what the value of negative 5 is, which is actually 0 also. So if you create a table, it's actually very helpful to see it visually. Now we need additional point. You can either substitute negative 2 or negative 6 because that's the next number we need to figure out. So if you use negative 2 in our equation, we will be able to find the y. So we're going to simplify this to get 4 minus 16 plus 15. 4 minus 16 is negative 12 plus 15 will give us a value of 3. So when x is negative 2, our y is 3, which is going to be when x is -6, it's also going to give us 3, again, because of our axis of symmetry. When we graph -2, we go up to 3. And if you graph -6, we go up to 3. And this is your graph called the parabola.